So now coming to the next video of the day, rather next question of the day. So you have to solve this limit. So as you all know by now, or you must be already knowing of course, that whenever we have to solve a limit, the first thing we do is we try to get which indeterminate form is it. So of course when you substitute x by 0, this is 0 and this is again cos 0 is 1, so 1 minus 1 0, so it's 0 by 0 form. So that's our 0 by 0 form, okay, no doubt about it. Now how will we start or how will we initiate? So now in that case, see, my suggestion is simple. I will say, okay, let's go for series expansion. See, in several many cases, instead of trying to apply the standard result, I prefer to use the series expansion, okay. So let's go for series expansion. So for that we need to know the series of exponential, which is 1 plus x square by 2 factorial plus x cube by 3 factorial, and then you can go on writing till you want. And then we need to know of course the series of our cos x also. Cos x is 1 minus x square by 2 factorial plus x raised power 4 by 4 factorial, or all even powers, okay, with alternate plus positive negative sign, and that also goes till infinity. Do we need series of sin x? Of course not, I won't be using it, but since it's there in the question, I mean the sin x term is there in the question, so I'm just writing it down. Sin x is an odd function, so you have all odd powers with alternate positive negative sign. So that's the way we could remember it, we can remember it easily, okay. So now let's put the value, but as I said, I won't be using for sin x. Why? Because I will say, okay, let's multiply and divide by root x. So this I can replace as 1, because we know sin t by t as t approaches 0 is 1, so we can remove it as a 1. So for denominator, for us the denominator is as good as root x, bachon, okay. So now let's put the values, okay. So therefore limit as x approaches 0, it's under root of 1 minus 1 plus x minus x square by 2 factorial, and then plus dot dot dot. Because why? Because see, we don't have e raised power x there, we have e raised power minus x. So if you have to write e raised power minus x, so wherever you have x, you will be replacing it with minus x. So that will make difference when you have where you have odd power of x, isn't that? Minus x cube by 3 factorial plus dot dot dot. Okay, so now this is, so that's it. So now the second term is again we have under root of 1 minus cos x, है ना, so it will be 1 minus 1 plus x square by 2 factorial minus dot dot dot, and then we have root x. See, now it's a very simple direct question because 1 gets cancelled. So what we get here is limit as x approaches 0 from the right hand side, of course, because of course we are getting root x, x has to be positive. Okay, so what is common in the first bracket? We have x common, so you will get root x out of it. So you will get under root of 1 minus x by 2 factorial plus something something something. Similarly, you have here x common, bachon. So you have 1 by 2 factorial minus maybe x square by 4 factorial, and then something something something, half and half, okay, by root x. Now if I cancel out root x, see again this is 0 by 0 form, and I think we would have discussed it earlier that if you have 0 by 0 form and the terms are algebraic terms, then you can have non-zero finite value only when the least degree, the degree of least degree term in both numerator and denominator matches. So it's matching here. Why? Because the least degree term in numerator is root x, x is power half, which is same as in denominator. So taking root x common, you cancel it out, you get root x here. Now as you replace x by 0, every other term goes to 0, every term except this one. So the answer according to me should be 1, bachon, okay. So chaliye, and I wish that those people who are regularly solving this question should share their answer. And if you have any better solution after watching this like videos solution here, then you should definitely share it with me, bachon. Okay, chaliye, so those were the 2 questions of the day here.